All right, this is Honors Algebra 2 Pre-Calculus. We're doing Unit 7.3 in Algebra 2. This is our fifth video, factoring with synthetic division. So we're going to pick up where we left off when we talked about using synthetic division as a way to factor. So how do we guess what numbers to use for synthetic division? So first thing, you're going to guess by choosing easy numbers. So when I say easy numbers, it starts with 1, not 0, and the reason for that is that if 0 were a factor of a polynomial, then x would be a GCF that you could factor out. So we're assuming that if 0 were a factor, you've already factored out the GCF of x, you've already found that factor. So the easiest number to start with is 1, and then try -1, and then 2, and -2, and 3, and -3, and so on. In section 7.5, we're going to learn another way to narrow down your choices a little bit. The other way to guess is to take the guess out of it. If you have a calculator, you can graph the function and then use your eyeballs to see what values should be zeros of that function. Like, what are the x-intercepts? Oh, hey, there's an x-intercept at 5. Great, I'm going to do synthetic division with 5. So you didn't really guess, you just knew that 5 would work. Once you do that synthetic division, when your remainder is 0, congrats, you found a factor. Write that factor down, and then continue factoring the quotient that you have from your synthetic division using all of the factoring tools you have available, right? The same normal tools we have, GCF, binomial, quadratic trinomial, grouping, all the way down to synthetic division again. If you don't get a 0 when you try your synthetic division, then that number didn't work, and try a different guess. This is sort of like the game Battleship. It can take a while to hit a factor, sort of like hitting a ship in the game, but once you do, the game escalates quickly. It's much easier to finish factoring once you've found something that one number that works. So let's go ahead and walk through an example. So we're going to fully factor x cubed plus 3x squared minus 13x minus 15. So let's go ahead and go through our checklist, right? We always do the checklist. There is no GCF. You can spot that because not all the terms have an x, and there's a coefficient of 1 here, so there's no way that there's a number in common. So there's no GCF. It is definitely not a binomial because there are 4 terms, and it's definitely not a quadratic trinomial both because it's cubic and because it has 4 terms. It does have an even number of terms, so you could try grouping, but if you try grouping, you're going to find pretty quickly that grouping fails. So if you try grouping, right, if you group these two and these two, you're going to pull out an x squared and be left with an x plus 3. When you pull out a GCF of the back 2 terms, you'll get a -1 and then something that is decidedly not x plus 3. This is not x plus 3, so grouping doesn't work. That leaves us with our last option, which is, hey, we have to do synthetic division, which, is not a surprise given that that's what this video is on. So you should do the checklist even if you're just doing it in your head, because if something has a GCF, trust me, it's going to make your life better to find it. So let's go ahead and take our first easy guess. We're going to try 1. So I try 1 as my first guess, and I write the coefficients across the top. I draw my big box, and then the little box goes under the -15. I don't need any placeholders because all of these powers, there's a third, a second, a first, and then no x at all. I drop the number down, I multiply and add straight down, right? I multiply and add straight down, and then I multiply, and I get a -33. Honestly, I don't even usually write the -33. I just write the word no, because I'm looking for a 0 remainder, and I didn't get a 0 remainder. So once I know that, I move on. Sometimes you can see it way before the end. Like sometimes the numbers are getting way too big, like way too negative, way too positive, and it's just not going to happen. Let's try it with -1. I drop the 1 down, I multiply and add straight down. I multiply and add straight down. I multiply. Oh, hey, we have a winner. Yay! Okay, so yay. All right, so here's what this means. I now know that x plus 1 is a factor, right? So that's what the -1 tells me, that x plus 1 is a factor, and that what's left is number x squared. What's left is x squared plus 2x minus 15. Now, this is a quadratic trinomial that I can factor. So what I saw originally looked like something I couldn't factor, but when I pulled out one factor, I was able to find other factors. So now I say, hey, this is a quadratic trinomial. I need this to be a 1 and a 15 or a 3 and a 5, and they have to have opposite signs. Okay, it's definitely a 3 and a 5. So I get x plus 1 as that first factor. And then since I want a positive 2, I'm going to do x plus 5, x minus 3. We should always FOIL to check, right? First is an x squared, check. Outer is a -3x and inner is a positive 5x. That would give me my 2x, and then last is a -15, and those are my 3 factors. Now, if I had put this in the calculator, if I were having trouble figuring out my first guess, if I graph this, if I go to y equals and hit graph, you'll see that I can see with my eyeballs that -1 works as a factor, so does -5 rather, and so does 3, right? I can see those factors. So it's not always going to be the case where all of your factors are super nice and friendly, but here they were all pretty nice factors. So let's go ahead and try a P11. All right, so go ahead and give this a try. Again, you're going to guess numbers. Now, you can go through the list. You should go through the list. There is no GCF. You can see that because they don't all have an X. They don't all have the same numbers. It is very much not a binomial. It is very much not a trinomial, right? If you try grouping, right, if you try to group, the trick here is that if you go back a step, so it's about the ratio of these values if you try grouping. And 1 to 3 is not the same ratio as negative 13 to negative 15, and that's why it didn't work. So if you tried grouping because there's an even number of terms, it's not going to work because you'd pull out an x squared and be left with an x minus 3. You'd pull out a minus 2 and be left with a 9x minus 20. See how these are not the same? That doesn't work, right? So you're going to have to go right to synthetic division. And again, that's probably not a shock given that this is the video on factoring by synthetic division. So try 1 first, right? You have a 1, a negative 3, a negative 18, and a 40. So the 1 drops straight down, multiply, add straight down, right? Multiply, add straight down. Oh, hey, not quite, but, you know, we're getting kind of a pattern there, right? So that didn't work. That's a no. All right, let's try negative 1. All right, 1, negative 3, negative 18, 40. And sometimes you have to go through a couple of these, but it's not a ton of work. You shouldn't erase it after you do it because it's an easy way to show that you should work. I drop the 1 down, I multiply, add straight down, right? Multiply, add straight down, right? And then multiply, and that's a no. I don't even have to write that it's a 54. Let's try 2. All right, so let's try the number 2, right? 1, negative 3, negative 18, 40. Drop the number down, multiply, add straight down, right? Multiply, add straight down. Hey, there's our winner. Okay, so this is a winner. What this tells me is that x minus 2 is a factor. That's what I get from this. And what's left is an x squared minus x minus 20, which is totally a quadratic trinomial that I can factor. I'm pretty sure we're looking at 4 and 5, because although 20 has a bunch of options, I want them to be opposite signs that come to a negative 1, so I'm pretty sure that's an x minus 5 and an x plus 4, and you can certainly FOIL to double check. But those are my factors, right? And if we were to graph it, if you're having trouble, if you get through a couple rounds, so perfect example, not on this video, but when I first did this and I had to re-record, I accidentally miscopied this negative 15 in example 11 as a negative 5. And so I went through like 5 or 6 rounds of synthetic division and none of them worked. And I knew that I had designed a problem where one of them should work pretty early. So I then put it in the calculator and realized what I'd done wrong was that I accidentally wrote this number wrong. So you should, if you don't get a hit by the time you hit like 3 or negative 3 or 4 or negative 4, stop for a second and see if maybe you miscopied a coefficient, because it's definitely a possibility. Now, the first hit that you got didn't have to be the negative or the x minus 2, right? Like maybe you inexplicably guessed 5 first and factored this out first. It's going to look a little different, but you'll end up with the same 3 factors at the end. All right, let's try another one. So this one's a little harder. I can pretty much jump right to synthetic division. Here's why. There's no GCF, right? And I can cross off 2, 3, and 4 because it's not a binomial, it's not a trinomial, and there are not an even number of terms. There are 5 terms. I can jump right to synthetic division here because without the even number of terms, I can't even try grouping. So I'm going to go ahead and try synthetic division, right? So I'm going to try 1, we'll do 1, 5, negative 11, negative 33, and negative 18, right? So I drop the 1 down, right? I multiply, add straight down, multiply, add straight down, multiply, add straight down, multiply, and that's a no, right? And as soon as you see it's not going to work, go ahead and cross it off. It's not the winner, right? 1, 5, negative 11, negative 33, negative 18. And you do need to make sure that that polynomial is in standard form. That's definitely a common trick. So I drop the 1 down, I multiply, add straight down, multiply, add straight down, multiply, add straight down. Hey, we have a winner, right? So that one worked. Okay, so now here's the trick though. I definitely have a factor that works, but this thing, right, so this thing here is still going to need synthetic division. And the reason I know that is I can see it has 1, 2, 3, 4 terms, so it's definitely not a binomial or a quadratic trinomial, right? It doesn't have a GCF because if the original didn't have a GCF, then I won't suddenly magically get a GCF. And it's not going to work for grouping because 1 to 4 is not the same ratio as 15 is to 18, right? It's not 1 to 4 is not the same as negative 15 to negative 18. So it's still synthetic division. So what's going to happen is I now have this first factor, right? So I now have one factor, it's an x minus 1. When I go to do my next round of synthetic division, the easiest way to do this, and I know it seems kind of lazy, but I'm just going to go ahead and pick up with my synthetic division right here and do synthetic division from that quotient, right? Now, so it's still synthetic division. A thing to notice about this, I started with negative 1 again. So why negative 1 again? Well, we've already ruled out that 1 doesn't work, but sometimes something is a factor multiple times. So sometimes x plus 1 is a factor more than one time, so I should start with the number that I got that worked if I'm going to keep doing this. So I drop the 1 down, right? I multiply, add straight down, multiply, add straight down. Oh, hey, I multiply, and look, negative 1 was a factor twice, right? So, negative 1 is a 0 twice, rather. So what that means is I now have two factors. I have the first factor, which was an x plus 1. I have the second factor that was also an x plus 1. It's a factor twice. And then what's left is this thing that is now a quadratic trinomial, right? This thing is a number, an x, and an x squared. So what's left is an x squared plus 3x minus 18, which I can keep factoring without synthetic division now. So what's going to happen is I noticed that if it's an 18 and it's supposed to have opposite signs that give me a 3, I'm pretty sure we're looking at a 6 and a 3. I know 2 and 9 are also factors of 18, as are 1 and 18, but since I want them to subtract to 3, right, it seems likely that what I'm looking at is a x plus 6 and an x minus 3. So my factors end up looking like x plus 1 times another x plus 1 times the x plus 6 times the x minus 3. Now the other way you might see this written, right, is with the x plus 1 quantity squared, because there are two of them, and then an x plus 6 and an x minus 3. So notice what made this one really tricky is I kind of have to keep doing synthetic division because when I got that first hit, when I got that first factor that worked, it still gave me something that I couldn't factor by any other method. All right, so let's go ahead and try a P12. Right, so same idea, and again, a little bit of a hint here is that sometimes you see repeat factors. Now this negative 1 didn't have to work twice. It just happened that it worked twice, so the factor appears twice, right? So let's go ahead and try this. Again, you can basically skip to synthetic division because there is no GCF, and then you can rule out 2, 3, and 4 based on the number of terms because it's not a binomial, it's not a trinomial, and it doesn't have an even number of terms. So you're going to jump right to synthetic division, right? So we're going to try 1 first, right? 1, negative 19, negative 11, and 30, right? And if something were missing, I would put a placeholder in, right? So I drop the 1 down, multiply, add straight down, multiply, add straight down, multiply, add straight down. Oh, hey, that's nice, convenient. All right, so I did give you some pretty nice synthetic division problems. So hey, we got our first factor, right? So from this, we now know that x minus 1 is the first factor. So that's the first factor, right? I'm going to go ahead and do synthetic division again now, right? I should start with the one that worked. It may not work twice, but I should try it and see if it works twice, right? So I try 1 again, I drop the 1 down, I multiply, add straight down, multiply, add straight down. Okay, so that's a no, right? So that's a no, so it doesn't work the second time. But I'm going to take this thing. This is the new thing I'm dividing, right? So this is my new polynomial that I'm trying to factor, right? That's what I'm trying to factor. And I'm going to go ahead and try negative 1. So let's try 1, 0, negative 19, negative 30. Drop it down, multiply, add straight down, multiply, add straight down. That's a no, right? And I don't have to find the number. I just have to see it's not 0. So let's keep going. So we're going to try 2, right? It's the next easy number to try. 1, 0, negative 19, negative 30. Drop the 1 down, multiply, add straight down, multiply, add straight down, multiply. Oh, close but no cigar because that's a negative, right? So that's a no. Okay, so it's not 2. Let's try negative 2. 1, 0, negative 19, negative 30. Drop it down, multiply, add straight down, multiply, add straight down. Hey, there's a winner, right? So yay! Okay, so we now get that this is a factor, so I now have my second factor is an x plus 2, second factor, right? And what's left is an we have a number, an x, and an x squared. So what's left seems to be x squared minus 2x minus 15, which is a quadratic trinomial that we can factor, right? So if we come down here to factor the whole thing, right, my answer, right, so my answer is going to be x minus 1, which is the first factor we found, x plus 2, second factor, and then this seems to be a 3 and a 5 with opposite signs, right, with that negative. So I'm pretty sure we have an x minus a 5 and an x plus a 3, and you can certainly FOIL to check that, but those are our answers, right? So again, that's an example where we had to do multiple rounds of synthetic division. Now, so far I've been giving you ones where all of the factors have a leading coefficient of 1. That's not always going to happen. Certainly there are going to be times that one of these is going to be a 2x minus 7 or something, but this is sort of the gist of how it works. So to wrap up the end of this video, we're just going to go ahead and do 2 word problems real quick. Just to get a little practice in. That's not to say that there's specifically synthetic division with factoring, but we should throw some word problems in where we can. So, word problem. An open top box is made from a 14-inch by 32-inch piece of cardboard, as shown at right. The volume of the box is represented by V of x equals x, which is the height of the box, right, x, times 14 minus 2x, which is the width of the box. I apologize if you hear noise in the background. They're doing street work outside our house. And the length of the box, which is 32 minus the 2x's that you cut out, right? The first thing they ask in A is to write the polynomial in standard form. A is just asking you to FOIL this thing out. So V of x, I'm going to save the x for last. I'm going to FOIL the other stuff, right? So when I FOIL this, I'm going to get 14 times 32, which I'm going to deal with later because I don't feel like dealing with it right first. Outer is going to be a minus 28x. Inner is going to be a minus 64x, right? And last is going to be a plus 4x squared. So I'm going to get that V of x equals, and I'm going to be lazy and do 14 times 32 in my calculator because it's early and the street work on my street is making my brain explode. All right, cool. So we're going to get 448. So we're going to go ahead and distribute this x. I'm going to get 4x. It's going to become a cubed, right, because there was an x out in front here, right? When I combine the negative 28 and the negative 64, right, you could either use a calculator or you can just add them yourself. I don't care. You're going to get a negative 92, so you get a negative 92, and it'll become an x squared because it was an x here, but there's an x getting distributed. And then lastly, I'm going to get a plus 448x, and that's my standard form of the volume, right? You weren't asked to do anything, just what's the standard form. And then for B, I'm asked to find the volume when the height of the box is 2 inches. Well, I'm going to suggest that you use the factored form because it's way easier, right? I'm going to suggest that you do 2 times 14 minus 4, right, times 32 minus 4. You're going to end up getting that this is a 2 times a 10 times a 28, right? So you're going to get that V of 2 is a 20 times a 28, which is a 560, and is much easier. And because it's inches, it'll be inches cubed because it's volume, right? And that's it, right? Now, you could certainly have plugged into your original that you found in part A, but I don't think it's worth it. I think it's much easier to plug into the factored form. All right, let's look at one more word problem for our P13. A pizza box with a lid is made from a 19-inch by 40-inch piece of cardboard, as shown below. The volume of the box is represented by 1/2 x times the 19 minus 2x times the 40 minus 5x, where x is the height of the box. And you can see, so this is 40, right? This is 40, but you're taking out 1, 2, 3, 4, 5 x's, right? That's why it's 40 minus 5x. And then the 1/2 comes because the box is actually folded right here, right? This is the length. This is the length of the box. If you fold it, the length of the pizza box is what happens if you fold the lid up and over. So here's our lid, right? The lid folds. It's terrible. I'm terrible at drawing. But the length, right, this is 1/2 of the 40 minus the 5x's you cut out. That's where the 1/2 comes from. So I mentioned that because when I looked at the problem, I thought, that's weird. Why is there a 1/2? So basically what's happening is the height of this box is x, right? The width of this thing is 19 minus 2x. So there's your height, right? Height, width. And then the length of the box is 1/2 of the 40 minus 5x, just so we're clear on where it comes from. You don't actually have to know where it comes from to do this problem, but I think it's helpful. So write the volume of the box as a polynomial in standard form. Okay, so that just means FOIL everything out, right? I'm going to save this for later, right? So when I go to do A, I'm going to go ahead and say V of x equals, and I'm going to leave the 1/2 out in front with the x while I FOIL everything else. When I FOIL, right, I get the 19 times the 40, right? And you can certainly do that if you want to do 19 times 40 on a calculator, you absolutely can. You can also try and do it in your head. I don't care. So I get 760, right? Outer is going to be a negative, so this would be a negative 50 and a negative 45, so it should be a negative 95x, right? Inner should be a minus 80x, and last should be a plus 10x squared, right? So I get that this is a 1/2 x times, probably clean it up a little bit, we'll put the 10x squared at the front, right? We get a minus 175x plus a 760 rather, right? And when I distribute the 1/2 x, I'm going to get that this is a 5x cubed, because the 1/2 times the 10, minus a 175 over 2x to the second, right? Plus a, probably that's a 38, right? So 380x, and that's my answer, right? Cool, so that's A. B, find the volume of the box if the height is 2, right? So B is asking me to plug in 2. So V of 2, well, I'm going to plug into the easiest option. I'm going to plug into the original that they gave me, right? Because it's easier to plug into that. So that's going to be 1/2 of 2, right? And then it'll be 19 minus 4, so that's a 15, right? And then it'll be 40 minus 10, which is a 30, right? So it seems to me that the 1/2 and the 2 cancel, and I just get 450 inches cubed, right? Because the 1/2 and the 2 cancel. 15 times 3 is 45, so 15 times 30 should be 450. And if we go ahead and do C, same thing, but they want it at 2.5 inches, right? So that's going to be a 1/2 times a 2.5, right? And this one might be one where you cave and plug into the calculator, right? Because this is going to be a 19 minus 5. Great, that's not awful. And then this is unfortunately going to be a 40 minus 6.25, which is less fun, right? So you probably cave and put it in your calculator, and that's totally fine, right? So 0.5 times 2.5 times 19 minus 5, right? Times 40 minus, and I'm probably going to do the 5 times the 2.5 just in case my brain did something dumb, right? 5 times 2.5, and we hit enter, and we get 481.25 inches cubed. And that's it, okay? So again, we were just being asked to plug in values, no big deal. And that is it for 7.3.